Ladies and gentlemen, we'll begin our program in just a minute. Ladies and gentlemen, welcome to Observing the Equinox with Griffith Observatory at sunset. My name is Dr. David Reitzel, and with me this evening is Patrick So, and we are very happy to be your host for this evening. Of course, our program is made possible by the City of Los Angeles and the Department of Recreation and Parks. Through the City of LA, Griffith Observatory is owned and operated by the City of Los Angeles. A lot of our programming is also made possible by our foundation, the Griffith Observatory Foundation, which is our nonprofit, private. Um, uh, anyway, they're our support group. They are there for us. They provide support for our events like this, so we thank them as well. But we're happy to be bringing this program to you from Griffith Observatory tonight. And indeed, we will be observing the equinox through sunset and into the evening. In fact, we're going to bring you some telescopic views. It is a beautiful evening here at Griffith Observatory in Los Angeles. So our telescopes look like we should be able to give you a view. I don't like to often promise things, but I'm hoping to give you some views after we watch the sunset up until about 9 o'clock. Now, of course, when you look at the sunset, if you want to look with your eyes, you need to look through the right kind of protection. Don't just go stare at the sun. Even at sunset, although it is much safer to do under some conditions, as you know, it's not going to be very pleasant. So if you really want to watch the sunset safely, watch it through the stream with us, or don't certainly stare at the sun for long amounts of time. It's not a very good idea. But Patrick will tell you why sunset is one of the times that it's much safer to look at the sun than others, and a little bit later. We will be observing the sunset, of course, and tonight we're going to look and see whether it falls down along one of our sunset lines we have out on our sunset terrace here at Griffith Observatory. This is actually not the one that will be falling along today. At least I don't believe it is from my knowledge of astronomy, but we will take a look and see. I will be out there on our sunset line and we'll take an exact look and see what's happening. Now today, of course, is March 20th, and today is the vernal equinox, or the northern hemisphere spring equinox, the southern hemisphere autumnal equinox. We're going into spring, first day of spring today. The southern hemisphere is going into autumn. So why does this happen? A little brief lesson on it. As you can see here in our diagram, the March 20th, the axis of the Earth is neither pointed towards nor away from the sun. It's actually kind of across it. So the Earth is getting even amounts of sunshine. When we come over to summer, on the first day of summer, on June 20th, 21st, I haven't looked up the exact date yet, the axis is actually tilted towards the sun, and the northern hemisphere is where most of the sunlight will fall down. That's why our days are the longest on that date. We're getting the most warmth from the sun, and indeed it's the first day of summer. By the time we swing back around over to autumn, into September, as you can see here, once again, that axis isn't towards or away from the sun, it's kind of across it. And now we're moving back across towards winter, and the northern hemisphere is tilted away from the sun. Southern hemisphere is their first day of summer, of course, it's the opposites, and they're getting the sunlight more directly overhead. The rays are more concentrated, the days are longer, which gives you more heat. It raises the temperature. Now, what does this look like from space? You can see here in our diagrams in the upper left, you can see our first day of spring here. The sunlight is straight up and down. Over here, it's tilted. This is the first day of summer. Northern hemisphere is getting more sunlight. And then a first day of autumn, first day of fall. Now let's see it in action. We'll put it in action here. I have to undo my laser pointer, put it into action, and take a look what it looks like from space. Now from here, the camera is tilting along with the Earth. So it looks like the sun is coming from different directions as they hold the Earth what appears to be fixed in space. But dramatically, you can tell that the amount of sunlight the northern hemisphere and southern hemisphere get changes throughout the season, throughout the seasons. Now, Patrick, a lot of folks think that we are warmer because we're closer to the sun in summer, but that's not quite true, is it?
Not quite true. It is sometimes it is a common misconception. As you can see, the Earth is actually closer to the sun in its orbit in January, and then it's farthest from the sun in July. But the difference between the closest and the farthest point in the Earth's orbit from the sun is only about 3 million miles, which is very small compared to the 93 million miles distance from the Earth to the sun. So we don't feel much of a change in terms of heat. In other words, being much warmer than in January compared to, even though it's northern hemisphere winter, it doesn't feel that much warmer. So,
no, it might make things ever so slightly more temperate. It will have a slight effect.
yes.
But it does cause an interesting effect. Our orbital speed, the Earth is moving faster in January. So we're actually cruising through space at a faster speed at that time, which is observable in the equation of time. It makes the exact moment of local solar noon drift. There's a lot of effects like that causes. So when you're close to the sun, even a little closer, you travel faster relative in space. So there is that effect. Of course, today, here's again our little diagram. The sun's rays, the sun's way off to the left, and the sun's rays are coming in perpendicular, illuminating the Earth such that exactly half of our sphere is lit, as always. But this time, the half that's lit, it's bisecting from the North Pole to the South Pole. So if you're standing right at the pole, the sun today would do a loop right around your horizon. It would be pretty cool to see. It would be straight off that distance. Today, however, like I said, we're going to go off and try and observe the sun coming down and seeing it come down along our sunset line. Now, why should it come down along a particular direction today? Well, if the sun is off illuminating the Earth exactly in half, it should set pretty much directly to the west. Now, we have a couple of things in line that might mess it up. There's some mountains that get in the way that we've had to maybe make a little adjustment for, and then also you can actually see a little beyond the horizon. The atmosphere actually bends those rays a little bit, and it does more than just bend those rays. It actually changes the perceived color of them, or the actual received color, not just the perceived, but the color we receive as the sun gets lower in the sky. And Patrick is going to tell us about why that happens. And as we can see here, this beautiful sunset shot. Where was this taken, Patrick? Was this up in maybe Tehachapi area? I know you like to go up there and see those mountains, although I'm not seeing any of those windmills, so I'm kind of confused.
Yes, well, this is actually created in a software called Terrigen. So it's actually CG, but as you can see, computer software for generating terrains and skies have become very advanced, and you can bring in almost realistic, photorealistic images such as this. I didn't have a chance to take a shot of this, but this was just basically a very beautiful
Yeah,
image of a sunset.
It's amazing in that the sun looks extra yellow there, so you've even changed the color. You've reddened the sun, as they say. So Patrick's going to tell you all about the colors of sunset. I'm going to run out to that sunset line right now. I'm going to put on my masks and get ready for sunset. So I'll see you all out there at the sunset lines. And Patrick, have fun telling about the sunset colors. I'm sorry to miss this, but I'll see you all again outside in just a little bit.
Yeah, sure. So sunset is and also sunrise are two of the most beautiful times of the day. And as you can see from this image, it is the colors of the sun actually change. Now, just a quick recap here. As during the day, the sun is brilliant. It's so bright you should, of course, not look at it. But the sky is bright. The sky is blue. And then later on in the day, when the sun moves towards the horizon, you notice there is a yellowing of the sun. And then eventually, when the sun is close to the horizon, it kind of turns red, kind of orange and red. And those are the beautiful colors that we see right at sunset. Now, why does this happen? Well, the clue lies in how the colors make up the sun, make up sunlight that interacts with the atmosphere, and how that sunlight interacts with the atmosphere. White light from the sun is composed of colors you would see in the rainbow. So even if you take a prism and you shine white light through it, you can split white light, which is basically into its component colors, which is the colors of the rainbow. Here we see nature doing that with sunlight. Now, to kind of get an idea of why these color, why sunset colors change, we're going to take a look at this diagram here. And there's an observer, and the sun is high above the horizon. And what we're going to do is the sunlight that's coming from the sun, we're going to look at the component colors of it in terms of primary colors like red, green, and blue coming from the sun. So as the light comes from space, from the sun, it enters the Earth's atmosphere. And let's go back here. So light comes through and enters the Earth's atmosphere. But you notice that some of the blue and a little bit of green is scattered by the air molecules in our atmosphere. Now, when that happens, that light is in the air, in the atmosphere above you, and that's what makes the sky blue. So a little bit of green and red is subtracted from the sun, making the sun a little bit yellowish, but the red is mainly unaffected. And this gives us our beautiful blue skies during the day. Now, the effect when the sun is near the horizon, the sun has to take a longer, sunlight has to take a longer path through the atmosphere. So most of the green and blue light from the sun, as you can see here, is actually scattered. It's scattered away from the sun, and only the red light, which is mostly unaffected, actually makes it through to your eyes. So if you were to take the arrows and the length of them and add them all up, you notice that the red component is actually the biggest, and so you would see the sun as a red and orange disk near the horizon. Now let's take a look at the numbers. The numbers in the blue circle show the percentage of blue, green, and red light removed from the sun when the sun is high in the sky. And you can see that 18% of the blue is removed, and that remains in the sky and scattered amongst the air molecules and makes our sky blue. When we look at what happens when the sun is close to the horizon, within the red circle, the numbers change dramatically, and most of the blue and green are almost gone from the sun, with only about 40% of the light of the sun actually getting through. So with this, scattering gives us our sunset skies, which we're actually familiar with. Now, this is a very interesting picture. These are the colors of sunset reflected um, in this picture rocket trail from the space shuttle. Now, why is this a second sunrise? Well, the picture was taken after the sun had set during launch, and as the shuttle ascended, the astronauts' view of if they were to look out the window as the shuttle was ascending into the sky, they would actually see a different view compared to what we would see on the ground. And as we look at it, we see the red, we see yellow, and then we see a brilliant white. So what's actually happening here? What you see here is the effect in these four images of the sun. So imagine if you were looking out of the window of your spacecraft. From the ground, the sun is already set, and as you move higher, you begin to see a little bit further over the curved surface of the horizon, and you begin to see that the sun is just right on the horizon, and that gives you the red in the smoke trail. And as you ascend higher, you get the yellow, and finally, if you're up at the altitude of the International Space Station, 220 miles above the Earth, the sun is completely above the horizon, except your horizon is now curved and has become the curved surface of the Earth. From the space station, you can see these really spectacular views. Here are some clouds lit up orange as the sun is kind of almost set at that point. But right below those clouds, the ground is actually dark. And if you were standing right below the clouds, the sun is actually below the horizon at this point. And here's another image from the International Space Station showing the reddening that occurs near the terminator, which is the line that divides light and day. Just an incredible sight that the astronauts get to see when they are up there orbiting around the Earth every 90 minutes. And if you could look towards where the sun is setting, the atmosphere is compressed, and even the sun is compressed as it sets just below the Earth's limb. After the sun is set, we're left with a fading blue twilight from the upper atmosphere. The astronauts above on the International Space Station get to see 16 sunrises and sunsets in a day. So this is a very, very beautiful sight, and we're about to actually, let's see what time it is. We're almost there. We're going to just go to a shot of the sunset. If we can bring that up before we go to Dr. David Reitzel at the sunset line, and then he will talk about the sunset. So this is a shot of the sun taken through a telescope, properly filtered, and I don't really see many sunspots here. But that's the sun at the moment as it is about to set. And if we're ready, we can go to Dr. David Reitzel.
Hi, ladies and gentlemen. Dr. Reitzel here. I'm out at the sunset lines, as you can see.
And there he
You'll
is.
be seeing sunset behind me from our camera view. It's a beautiful evening out here at Griffith Observatory, and we're going to have a beautiful sunset. Let me tell you a little bit about what is special about today, and I'll try and speak up for our crowd that's over here. They're being socially distant. They're not allowed too close to us to keep things safe here. But we are looking forward to one day when we can host this in person. But tonight, thank you so much for joining us online virtually to watch the sunset on the equinox. Now, why is the sun setting along this line today? Well, it has to do with the fact that today, indeed, the Earth's axis is neither pointed towards nor away from the sun. In fact, the observatory itself is lined up north, south, east, west, such that the building is oriented along the direction the sun rises, passes through the sky, and then will set off in the west. And we can predict those directions depending on the time of year. And in fact, in the summertime, when the sun is rising way, way, way off in the north there, arcs high up over the sky, takes a path very high in the sky, and comes down, sets way off in that direction, we have a line over here that shows that. You can see here, we have our summer solstice sunset line this far over. It's quite a long distance over, and that's because the Earth's axis is tilted by 23.5 degrees. It changes the direction of sunset by that amount. So today, it's going to set due to the west along this line, but in wintertime, as you know, when the sun takes a very low path through the sky, arcs up, doesn't go very high in the sky, comes down and sets, it actually sets all the way over in this direction, as you can see. You can see our winter sunset line right here. Now, you might notice there are some other lines on here. Those are actually what are called moon standstill lines, and, well, they don't apply for today. They don't apply for the equinox, but they are very interesting, but they're on a much longer time scale. So we'll talk about those in the future when we're having a moon standstill event for you all. But today, we are going to watch the sun and make sure it actually goes down in the predicted direction straight to the west here in Los Angeles. And indeed, it does look like the colors are starting to change a little to me. The sun is getting redder as it gets down into that haze that is scattering that blue light out of the way. So here at Griffith Observatory, we bring you this information and bring you this experience courtesy of the City of Los Angeles, the Department of Recreation and Parks, and of course with generous support from our private nonprofit partner, the Griffith Observatory Foundation. And you can see a link down below in the description section. If you like this stuff we're doing, go ahead and join, become a member, and you get more benefits, more activities like this. So, ladies and gentlemen, if you're enjoying this, stay tuned for the rest of what we're doing tonight. We're going to bring you live telescope views from the roof. We have plans to show you the moon, and perhaps even the Orion Nebula. So, hang in there and enjoy this, and happy first day of spring. So enjoy the sunset. We're just going to watch it go down together and have an enjoyable evening with some music. Thank you, and enjoy the equinox.
And okay, folks, the sun has gone behind the hill, but it doesn't officially set until about 7:05. So it's right behind the hill.
Well, folks, I made it back to my office. I hear Patrick talking about how it's behind the hill. Indeed, we had predicted the time that it would set would be 7:03, and it looks like we did pretty close to that. That's, again, like Patrick said, the time more like the horizon time. It's behind the hill. It's probably beginning to make contact with that horizon, but it was a beautiful sunset out there. And we got some very good shots, so thank you to our crew up there with the telescopes. And I do love seeing that sun go behind that hill from that telescopic view. That's very fun to see. So I do know that soon we will start doing some telescopic views. We'll bring you the moon in the near future. But Patrick, have you told them about colors maybe on another planet, what sunset might be like somewhere else yet?
No, we haven't actually ventured to that planet yet, although we did land a rover there just last month. So,
yeah, well, that was. I'm super curious to hear how would it be different on another planet? Do we have any way to investigate that?
yes, we do. If we can go to the slides if we want to do that right now. Right. Okay, well, you guessed it, the planet Mars. We landed the rover Perseverance there last month, and Mars is a interesting place. It has a very thin atmosphere, and you can actually see this in this picture, which was taken by a Viking orbiter many years ago. That thin kind of orange line there, just above the planet Mars, kind of with all the craters back there. And there's also some streaks in the atmosphere, which is the dust in the atmosphere. But Mars's atmosphere is 100 times thinner than the Earth's atmosphere, and being farther away from the Earth, it only receives half as much sunlight compared to the on its surface compared to the Earth. So that would make a very interesting combination for what the sky would look like from Mars. We've seen pictures, and this was a recent picture taken a few days after the Perseverance rover successfully landed on Mars. This picture was taken when the sun was just above the horizon, but not too far above the horizon. You can see kind of almost in the central left of the picture, that kind of glow, kind of yellowish glow. And that's from the sun. That's lighting up the atmosphere of Mars. And then just to the left and the right, the atmosphere kind of turns into a gradient, turns into a kind of like a brownish color. So that's what the sky would look like when the sun is near setting. Now, for an actual sunset, here is a picture that was taken by the other rover, Curiosity, right at Gale Crater. And you can see that it doesn't look like a sunset here on Earth. It looks like the sun is setting in through haze or through some clouds. But you can see a distinctive blue there, blue tinge around the sun. Next one we have is just a sequence of images taken from, actually, that was the same picture, but it has a sequence here. And what we see here is a span of, let's see, a picture taken of a span of 6 minutes and about 51 seconds exposure. And you can see that what happens with the change of light as the sun begins to dip below Mars's horizon there. Now, what's really giving us this blue color? Well, it's mainly the reddish dust particles, and it's very fine in the Martian air. And that dust particle is kind of reddish, and it kind of reflects and scatters the red component of the sun's light away from the direction that you're looking towards the sun. And what you end up with is only the blue light is getting through. And hence, when you look at the sun as it sets, it just looks like it looks kind of blue and gray, and around and further away from the sun, the sky kind of changes into a dark brownish hue. And then I think one final picture is just more color saturated picture, just to show how much blue there is around the sun at sunset. So unlike Earth sunsets, which are very pretty and have all colors of the rainbow, future explorers will be treated to blue sunsets on Mars.
Well, one day we'll get there and we'll be able to see that, and we'll all be enjoying those sunsets on Mars. Right now I'm enjoying a bit of an allergy attack. Sorry, people. I had to drink a little water there. Anyway, it's been a beautiful evening here at Griffith Observatory so far, and we've got more coming up. We've got some telescope views that we're going to bring you of the sky, and I think we probably have switched over pretty soon. Do we have the moon yet to show folks up there? Let's take a look here. We'll see what our switchers tell us, because very soon I'm sure we'll be able to. So he's in process right now. Our telescope demonstrating is what's called slewing the telescope over from the direction off to the west to get it over to the moon. Of course, he had to remove the solar filter. The moon is not so bright that we need to filter it. That was, of course, a filtered view that you got to see in the picture-in-picture. A lot of you noticed that that was upside down as well. That's, of course, due to the telescope optics that flipped the image upside down. So kind of a fun surprise to see the sun make contact with the mountain at the top as it was setting from off to the side. All right, so I guess we have the moon. So let's take a look and see what we have. And then we're also going to find, so that is a nice looking view right there. This is very close to a first quarter moon. We're just past first quarter. First quarter, by the way, illuminates half the moon from where we can see it. So it's a little bit of a misnomer in a way, but it is the first quarter of the orbit. It is a quarter of the way from new moon towards being full. So it's almost exactly half lit. And you can see here, they're still making some adjustments there. You're seeing a little bit of our panels coming up. One obvious thing you're seeing right off the bat are some craters. We get some crater view there along what's called the terminator, which is the line between the sunlight and the night side of the moon. Now, by the way, the moon does experience days. They happen to be the length of the lunar month. So there's no, one side of the moon doesn't stay dark, but at any given moment, half of the moon is indeed in shadow and is dark. When that half of the moon, sometimes part of it gets a little bit illuminated by what's called earthshine, and you'll see a little glow on the dark side, and that's light that's bounced off of Earth and is illuminating the moon. But today we're getting a very nice look of the moon along the terminator there with some beautiful craters. Patrick, do you notice any of the features on the moon right now?
Well, on the lit side, there's a circular feature kind of in the kind of area. I wish I could point this out, but if you notice near the day and nights line, there's a circular feature, and just above that is the Sea of Tranquility, where Apollo 11 landed.
Yeah, indeed. We are staying very close to that location, and we can't quite point that out to you. We don't have the ability to laser point on this beautiful image. And boy, it does look good. I just opened up the YouTube stream, by the way, and it is quite the nice looking image we have for you tonight. There's a little bit of, you can see the image drifting a little bit, shaking slightly. That is due to the wind. We are not bringing this from our dome tonight, but from one of our smaller telescopes that we have set up next to our streaming equipment. So I'm seeing some bright rays. You can notice some lighter white areas on the moon that look like they're straight lines. Indeed, some of those are material that were thrown out of craters, out of an impact, and the material was thrown across the moon and left these straight line features. So a very nice looking shot of the moon. And as soon as we track down some of our planetary music, I'm going to track that down for us here. We're going to switch over to music, and we'll enjoy beautiful shots of the heavens, our moon, and perhaps the Orion Nebula a little later. and enjoy the music. If you have questions, feel free to put them in the chat. Our staff is there to answer them, and we'll come on every once in a while and talk a little bit more, but we'll mostly let you enjoy this beautiful equinox moon.
Ladies and gentlemen, Dr. Reitzel of Griffith Observatory here. I hope you're enjoying this evening's program. You're seeing live views of the moon from Griffith Observatory telescopes right now. Today is the equinox as well. So we've been celebrating today's equinox, the spring equinox for the northern hemisphere, the autumnal equinox for the southern hemisphere. And we're playing some of the beautiful music from our planetarium shows as you enjoy these views. If you have any questions, feel free to chime into the chat. We have some moderators in there to answer questions for you. And if they can't answer any of them, they'll try and pass them along to us, and we'll see if we can get back to you. Otherwise, we're going to get back to the music and let you enjoy the beautiful view of the moon. And then later tonight, when it gets a little darker, we're going to switch over to the Orion Nebula and see if we can get something that looks good from it. Enjoy the equinox, everybody. Happy spring.
Okay, welcome back to our coverage of the equal sunset. We've already had the sunset. We're looking at a live image of the moon, but we're about to reposition the telescope and point it at the Orion Nebula. And while we're doing that, I'd like to talk a little bit about the night sky, as you can see it from Los Angeles. I have my chart up here, and okay, well, the twilight has begun to fade over in the west, and up in our sky, right at the top there is the actually the waxing crescent moon, which we had our telescope on just a few minutes ago. But below that is the planet Mars. Mars is visible, but it's not as bright as what it was last year when it was closest to us. Mars is still visible. It's just a faint reddish starlight point in the sky just below the moon. It's in the constellation of Taurus, and Taurus' brightest star is called Aldebaran, and that star is actually marks the eye of Taurus the bull, and it's kind of similar in color to Mars, although a little bit more orange. Just to the southwest, a little bit to the west of Taurus the bull, is the constellation of Orion the hunter. A winter favorite, but now we're in spring. It's still visible in our evenings, but the sun will later catch up to it in a few weeks, and it will become low on the horizon in the fading twilight. But Orion is marked by 3 stars in a row. That marks its belt, and the stars themselves form a line. And if you draw a line down from the belt downwards, you find the brilliant star Sirius, the brightest star in the night sky. Above Orion are 2 stars, actually. There's one that's kind of reddish in color on the left side of Orion, and that is the star Betelgeuse, red giant star. And it varies. Last year, we saw a variation in this star where it was a little bit fainter than usual, and now it's back to its normal brightness. To the right of that, and a little bit down below, is the star Bellatrix, which is the other star in Orion's, actually Orion's shoulders. So 2 stars above the belt marks Orion's shoulders. The star below the belt, the bright one, is called Rigel, and just to the east of that is a fainter star called Saiph. So that's our night sky as you can see it from Los Angeles tonight. And just below the belt of Orion, I've marked there M42. M42 stands for Messier 42, which is a 42nd object that was seen by Charles Messier as he was cataloging objects that he wanted to distinguish from comets. M42 is the Orion Nebula, and that's where we're going next with our telescope. We're going to be pointing to that region of the sky just right below Orion's belt for M42 Orion Nebula. So let's stand by, and we'll have our crew reposition that telescope, and hopefully we'll be bringing an image of the Orion Nebula, which is 1,300 light years away from Earth, to this screen.
Hi, ladies and gentlemen. Dr. Reitzel here, live from the roof of Griffith Observatory, where this image of the Orion Nebula is coming from. That little bit of shaking you're seeing is due to the wind. We'll try and control that the best we can throughout the night. This is a beautiful star-forming region, of course, as you can see there. It's just a beautiful place where stars are being born. Young baby stars are there, and enjoy this view all night long with our planetarium music. Well, up until the next hour or so, we're going to end our night close to 9 p.m. So up until then, enjoy this beautiful view of the Orion Nebula. Ladies and gentlemen, maybe you've noticed the picture's gotten a little bit worse here, a little bit shakier. The wind has really picked up here at Griffith Observatory. We're still going to provide this view. It gets steady every once in a while, but that shaking is not an earthquake. And now you're seeing the image get focused a little bit here, trying to get it a little clearer for you. But we'll keep trying to do our best. We'll keep trying to bring you the best image we can. And we're just putting up with the elements like anybody else on this first day of spring. So enjoy this view of the Orion Nebula from Griffith Observatory. We are owned and operated by the City of Los Angeles and the Department of Recreation and Park. And we're also, we have a public nonprofit partner in the Griffith Observatory Foundation that supplies us with a lot of support for much of our mission. So it's a great cooperative mission between us. But thank you so much for joining us here from Griffith Observatory. Enjoy this view. Ladies and gentlemen, Dr. David Reitzel here from the roof of Griffith Observatory, where we've been coming live and bringing you live views from our telescope. As you can see, we've been showing you the Orion Nebula, a beautiful star-forming region that's in the sword of Orion. It's sort of the middle star of the sword that you've been looking at. It's actually a collection of stars that are forming in a cloud of gas. Unfortunately, the wind has gotten quite strong up here, and our image is getting really pretty bad. So we're going to shut down observing for the night. We're going to sign off and wish you a happy spring and enjoy it the rest of your spring here. We'll come back to you on our summer solstice is our plan. Before then, we actually have a lunar eclipse that's coming up in May, so look for that. And if you've enjoyed this program tonight, be sure to subscribe to the channel. Be sure to give it a thumbs up. You want to hit that notification bell as well if you want to be notified every time that we're broadcasting. And then, of course, lastly, down in the description, there is information about how to join our foundation, how to sign up for our newsletter, and how to follow our other programming at All Space Considered. Tonight's broadcast has been made possible by, of course, the City of Los Angeles and Griffith Observatory and the Department of Recreation and Parks. And we'd also like to thank the Griffith Observatory Foundation, who is our nonprofit public partner for much of what we do. So thank you again, everybody that's joined us today for our local noon celebration and for tonight's sunset celebration and for the observing as we're all hanging onto our hats here as the wind is really getting strong. So we're going to sign off, and happy spring to you all. Thank you very much.